So here we have our acceleration being 40 kilograms plus 10 kilograms times 10 Newton per kilogram, which is gravity on Earth, divided by 30 kg, which is the mass of A, 40 kilogram, which is the mass of B, and 10 kilogram, which is the mass of C. When we substitute, we get 50 kilograms times 10, which is 500 Newton divided by 80 kilograms. When we divide that, we have acceleration equals 6.25 meters per second squared. Now we're going to be looking at part B, and the question says how far does it move in the first 0.250 seconds? So we have to first decide on an equation for this, and S is distance. You know, we thinking of this formula would be perfect because S equal UT plus half AT squared would, you know, it has in time, and we are trying to find the distance, as it says how far. Our initial velocity is 0, and we have our time and our acceleration, which we just found. So substituting the values, U is equal to 0, T is 0.25 seconds, plus half, and of course acceleration is 6.25 meters per second squared, times T squared, which is 0.250 seconds, times 0.25 seconds, and that turns out to be 0.39. I have to work out this section here, divide by 2, and our distance is 0.20 meters. So that's how far it moves. Now we're going to be deriving an expression for the acceleration of each system, that is for each of the ballot box, when drag forces and friction are included. So we're going to start by looking at block A, and that is equal to T1, which is equal to MAA. And of course, if we substitute for A, we have T1 minus Fr, which is a frictional force, divided by MA. So the expression now, we can, you know, based on the fact that frictional force is equal to mu n, where n is equal to the weight because it is in the horizontal, we have this substitute Fr for this here. So it is now T minus mu n, divided by MA. Now we're going to continue by looking at block B now. So for block B, there is no coefficient of friction, only drag that will be acting. Because drag is acting upwards, which is the same as T1. So if we should look back at the picture here, diagram here we have our drag force. And of course, we have our T2 right here. So drag is acting upwards, which is the same as T1. So let's look back at the working out now. So T2 plus MBG minus T1 is equal to MBA. T2 plus MBG minus T1 minus FD, which is the drag force, is equal to MBA. And our final expression for the acceleration will be T2 plus MBG minus T1 minus FD divided by MB. We're looking at our next ballot box, which is block C now. And drag is in the same direction as F2. So here we have our ballot box C, and we're going to write the formula for it, the expression. So it's MCG minus T2 minus FD equal MCA, and our final expression, if we transpose for A, is equal to MCG minus T2 minus FD divided by MC. And what we realize is that the acceleration is less in each case, and the resistive force makes the acceleration less.